Okay, so this was the experiment that we did last week. Okay, the homework that I gave you last week. So it's about an experiment to measure the rate of reaction. Okay, so this is hydrogen peroxide. Okay, this is hydrogen peroxide with hold on, I don't know why my pen is not working. Give me a minute. Eh, it cannot again lah. Do you all remember this from last week? Yes, Okay, so what happens is it releases hydrogen peroxide, releases oxygen, and the gas is collected here in the gas syringe. Okay, it's collected here at the gas syringe. Okay, so W and X are both catalysts, the breakdown of hydrogen peroxide. Okay, the syringe diagram shows the volume of oxygen formed every 20 seconds at 25 degrees Celsius. Okay, so you're supposed to fill in this lah. This is a very simple thing. You just fill in the graph. Okay, now, so you just have to copy from the measuring cylinder here. Okay, the readings, and then you have these readings. Okay, so which is a better catalyst? Okay, so plot a result. Plot a graph to show each set of results and label clearly on the curve. All right, so you, okay, now what is it that Ihua forgot to do? If you look at this, yeah, just now when you did it, it was working. Now it's working. Wait, let me make it smaller first. Okay, so what is it that Ihua forgot to do? If you all look carefully, what did she forget to do? She forgot to label her X and Y axis. Other than that, everything is fine. So here would have to be volume of oxygen gas, and then you have to put your unit centimeter cube, and then here she would have to put time and then seconds. Okay, now she had two graphs. One was for catalyst W and one was for catalyst X. So you have to put in all the information. Guys, this one you stare at me, you cannot understand. You must sit down and do the graph. This experiment, a lot of graphs, okay? This question, a lot of graph. So you have to sit down and do the graphs yourself. So this is how your graph should look like. Catalyst W and catalyst X. Understand? Okay, so you will have two curves on the same X and Y axis. Okay, so the only thing Ihua forgot to do is she forgot to label. Alright, other than that is okay. And very smooth graph. She plotted everything properly and everything. Okay, so let's look at the next question. So based on your graph, which is a better catalyst? Give a reason for your choice. Okay, so if you look at this, which one is faster? X is faster or Y is faster? X is obviously faster, right? Okay, so because X is faster, X is a better catalyst. Okay, so higher rate of reaction. So which is a better catalyst? Give your reason. So X, higher rate. Why is the final volume of oxygen same in each experiment? So in both experiments, I can only have one variable that I change. The only variable that I change is the type of catalyst. But the hydrogen peroxide, the volume, the concentration, the amount, everything has to be the same. The only thing that I can change is the catalyst. So in the end, I will have the same total volume, 37, 37. I will have the same total volume. Okay, that's why it will have the same, because I have the same amount of hydrogen peroxide used. Okay, sketch a line on the grid to show the shape of the graph you will expect if the reaction with catalyst X was repeated at 40 degrees Celsius. Okay, you repeat everything at 40 degrees Celsius. Now, how do I know what happens at 40 degrees Celsius? So you look at this. The question says that this is done at 25 degrees Celsius. Okay, the question already says this is done at 25 degrees Celsius. So at 40 degrees Celsius, it will be faster. Okay, so all you need to do is, now remember, this is sketch a graph. You cannot go and draw a whole graph all over again. So on this graph that you do in your exam, this is your sketch. You have to show a higher rate of reaction. A higher rate of reaction shows that it's higher, and then but it ends at the same place. Can you see that? It ends at the same place. Okay, so this is how your graph should look like. Okay, so I really need you all to do this. This is not something I can just teach. This is something that you have to physically go and do. All right, so can you guys do that? Gahe, Matthew, Ziyu, can you all do that? Yes, okay. Now, so let's talk about what we're going to learn today. Anyone? Oh my goodness, this is so annoying. It keeps disappearing. Okay. Surface area, thank you. Okay, so the first is particle size. Okay, the first is particle size. Okay. Okay. When the particle size is smaller, the total surface area is larger. Okay, we talked about that already. Okay. Now, the second one is concentration. Concentration only applies to aqueous solution. Now you have to remember, this one is aqueous solution and not a solid. Okay, aqueous solution and not a solid. Okay. Okay, now what happens is, the higher the concentration, the higher the rate of reaction. Okay, why is that? Because in a solid, in a aqueous solution, this is the aqueous solution, right? This is diluted. This is how the particles look like when it's diluted. And this is how the particles look like when it's concentrated. There are more particles in this particular surface area. So what happens is, when the concentration is higher, we don't just say more particles, we say more particles in the same volume. So it's more particles per unit volume. Okay, more particles in the same area. It's like the shopping mall lah. The shopping mall on Friday and the shopping mall on Sunday. Which one is crowded? Of course, the shopping mall on Sunday. It's more crowded. So we say the concentration of people are higher. More people per volume. The shopping mall doesn't become bigger, but there are more people in the mall. Okay? So when the particle size is smaller, the surface area is larger. When the concentration is higher, there are more particles per unit volume. The same actually applies for gas pressure. So I already told you pressure is only for gas. So this is low pressure. Okay, those of you who have learned in physics, you already know this is low pressure. And this is high pressure. Okay, this is high pressure. So what happens is over here, the particles are further apart. Over here, the particles are closer together. Okay, so the concept is the same. When the pressure is higher, concentration and pressure, same thing. When the pressure is higher also, we say there are more particles per unit volume, meaning that the particles are closer together. Okay, when the particles are closer together, who can remember what I said about last week? Okay, what I said about last week. What must occur for the particles to react? The particles must what? Collide. Okay, the particles must collide. The more often the particles collide, the higher the rate of reaction. Okay, the more the particles collide, the higher the rate of reaction. What happens is when the concentration is higher or the pressure is higher, the particles are closer together, so they will collide more often. The same applies to surface area. The larger the surface area, the more particles will collide together. Okay, so more collision. Or we actually use this word, they collide more frequently. Who is that? I just came in. Oh, Maybelline just came in. Okay. All right, they will collide more frequently. Frequently means more often lah. Or they use another term, collision frequency. Collision frequency, I mean you learn frequency in physics, right? Frequency means how often something happens. So we say the collision frequency increases. Okay? Now, just because two particles collide doesn't mean there is a reaction. Sometimes there is a reaction, sometimes there is no reaction. What happens is when there is a reaction, it's called successful collisions or effective collisions. Sometimes they just collide but nothing happens. There's no reaction. Sometimes they collide and there is a reaction. That is called a successful collision. Okay? So, more successful collisions or more effective collision. Okay, so when there is more successful collision, the rate increases. Okay, now this is a 4-mark essay. Okay, what happens when the particle size is smaller? When the particle size is smaller, the total surface area exposed is larger, the collision frequency between particles increases, there is more successful collisions, and the rate of reaction is higher. What happens when the concentration is higher? When the concentration of the acid is higher, there are more particles per unit volume and the collision frequency increases and there's more successful collisions. Okay? What happens when the pressure increases? When the pressure increases, there are more particles per unit volume, the collision frequency increases, more successful collisions, and the rate increases. So in the end, as long as all of this happens, the rate increases. Okay, so this is commonly what they ask you in IG. Okay, but not yet finished. Okay, so we have these important things: particle size, concentration, pressure. Got some more. Okay, temperature. Now, temperature is very important. Temperature is a very frequent question in rate of reaction. Okay, temperature is a very frequent question in rate of reaction. Now, what happens here is when the temperature increases, two things actually happen. The particles have more of the particles have more kinetic energy. You all know what's kinetic energy, right? Kinetic energy means they move faster. So particles have more kinetic energy. In chemistry, the symbol for kinetic energy is EK. Okay? In physics, the symbol for kinetic energy is KE. Why is it like that? I have no idea. Okay? But everybody knows what's kinetic energy, right? EK, kinetic energy. So when the temperature increases, the particles have more kinetic energy. Now, another term I'm going to teach you right now is something called activation energy. Okay, what is activation energy? Okay, so let's look at this. Now, we talked about the particles colliding. Okay, we talked about the particles colliding. When the particles collide, they must have a certain amount of energy. It's the same as you buying something in a sale. Are you buying something? Okay, let's say no sale first. Now COVID, a lot of sale, right? Before that, let's say the price is RM 10 ringgit. Okay, it's RM 10 ringgit for these sweets, let's say. Right, RM 10 ringgit for the sweets. Some people who have RM 9.9, can they buy the sweets? Can or cannot? Can you go to the shop and tell the uncle, I only have 9 ringgit 90 cents, but I know your thing is 10 ringgit. Can I buy? Of course not. Not enough. Not enough money to buy. If you have RM 9.7, also not enough. If you have RM 9.99, also not enough money. You must have RM 10. So if this person has RM 10, yes, this person can buy the sweets. If this person has RM 11, got anyone so stupid say, oh, the price is RM 10, you got RM 11, cannot? Of course not, right? So RM 11 also can. So the minimum the person must have is RM 10. This is the minimum. Okay, the minimum amount of money that you must have is 10 ringgit. Okay, so in a reaction, the minimum energy that the particles must have in order for a reaction to happen is called activation energy. And the symbol for activation energy is EA. Okay, so activation energy is the minimum energy the particle must have in order for a reaction to occur. Everybody understand? Okay. Hello, can you guys respond? Do you all understand? All right. Okay. Now, what happens is when you give particles more energy, okay, when you give the particles more energy, of course, they have more kinetic energy, and of course, more of the particles can achieve activation energy, okay? So in IG, it's very specific. They will always ask you this question about temperature, and you must always answer these two things. Why is it when the temperature increases, the rate increases? Because more particles have activation energy and the particles have more kinetic energy. So the particles will have more collisions and they will have more successful collisions and the rate of reaction increases. Okay? So can you all understand so far? So this is how so they can ask you about, this is especially for SPM. Like SPM, you will learn the same thing and it's actually the same sequence. Okay? So for IG, usually 99.9% of the time they ask you temperature, sometimes they ask you concentration. Sometimes they ask you particle size, but a lot of times they ask you temperature is a 4-mark question because you must talk about temperature increase, particles have more kinetic energy, more particles achieve activation energy, more collisions, more successful collisions, and so on. Okay? Now, so this is particle size, concentration, pressure, temperature. The last one is catalyst. So the homework that you did, the experiment was about catalyst. When you have a catalyst, suddenly the reaction becomes very, very fast. Okay, the catalyst must be present. We don't say the catalyst is more or the catalyst is less. We just say the catalyst has to be present. You just need a little bit of catalyst. Catalyst is like enzyme like that. You just have to be present. Okay, now what does a catalyst do? A catalyst doesn't increase the temperature, doesn't increase the kinetic energy, doesn't increase the concentration, doesn't increase the particles per unit volume, and doesn't increase the surface area. So what does a catalyst do? A catalyst is very special. Okay? RM10 just now was the minimum amount. That was the activation energy. So only these two guys could buy. Only the 10 ringgit and 11 ringgit people could buy. The 9 ringgit 90 cents cannot buy. The 9 ringgit 9 ringgit 70 cents also cannot buy. Even the 550 people cannot buy. All cannot buy because they got not enough money, not enough activation energy. What happens is suddenly you add a catalyst. A catalyst does this magic of discount. Suddenly it's RM1 discount. Okay, catalyst is the only thing that can lower the activation energy. It can lower the EA. Okay, by lowering the activation energy, just now those people with enough money also can react. These people just now with not enough money also can react. Basically, everybody can buy now. Do you understand? Do you understand what a catalyst does? A catalyst doesn't increase the temperature. A catalyst doesn't increase the pressure. A catalyst just lowers the activation energy. Okay? So I have to write a bit further away after you get confused. Eh. Wait ah. Sorry, today my pen all terbalik a bit. Okay. More particles achieve EA. Okay, but catalyst is different. Just has to be present and it will lower EA. Now, when you lower the activation energy, one very important point that you need to know is when you lower the activation energy, you don't have more frequent collisions. They're not moving faster, but they have more successful collisions. It makes it easier for a reaction to occur. Okay? Can you all understand so far? Okay. Can you read this? Can you read this? Okay, I'm doing screen recording, okay? I'm doing screen recording. So don't worry about the recording of it. I know I know you guys can't really catch. Maybelline's in the car, right? So can't really catch. Okay, so it's hot. Okay, the aqueous sodium thiosulfate dilute hydrochloric acid are mixed together. Okay, so this one, yes, it produces a gas. Okay, yes, it produces a gas, but this gas cannot be collected. Okay, this gas cannot be collected because it will dissolve back into the solution. Okay, so what we want is we put an X underneath. Okay, and the time taken for the X to be completely covered by sulfur, because sulfur is a solid. It is a yellow solid, so it will cover the X. So we say time taken for the cross to disappear from view. Or sometimes they will just put in the exam, time taken for the cross to disappear, time taken for it to whatever lah. Okay, so a student adds the following volumes of aqueous sodium thiosulfate to dilute hydrochloric acid. The time taken for the precipitate of sulfur to make the cross disappear from view is recorded. Okay, so experiment 1, 2, and 3. Okay. Okay, so we haven't done this. We haven't done this yet. They haven't told us to fill in the blanks. Okay. Now I want you to read this carefully. Read question A carefully. Do you understand what question A is asking you or not? The thing about with the order, so meaning, right, who do you put in first? You have to add in 3 things, right? You have to add in these 3 things. You have to add in sodium thiosulfate, you have to add in hydrochloric acid, and you have to add in distilled water. Why do you add distilled water? Okay, you see, the distilled water is mixed together with the sodium thiosulfate. This is to dilute it. Okay, so this one has a lot of sodium thiosulfate. A little bit of sodium thiosulfate, a lot of water. But when you take 40 and 10 add together, the total is 50 centimeter cube of solution inside here. The total must be 50 centimeter cube. So it's this 50 centimeter cube is 10 of sodium thiosulfate and 40 of water. So that is experiment 1. Okay. Then when you do experiment 2, what you do is experiment 2. Now experiment 2 is more concentrated or more diluted? Hello. Experiment 2 is more concentrated or diluted? Seriously, come on, look. Experiment 1, I put 10 centimeter cube of sodium thiosulfate. Concentrated. Experiment 2, I'm putting more. Experiment 1, I put 1 lump of sugar. Experiment 2, I put 2 lumps of sugar. Which one is sweeter? Experiment 2 lah. Experiment 1, I put 1 lump of sugar and 4 cups of water. Experiment 2, I put 2 lumps of sugar and 3 cups of water. Can you understand? No. It is dilute hydrochloric acid, not diluted hydrochloric acid. You see, the hydrochloric acid is always the same one. We don't change the hydrochloric acid. We add the hydrochloric acid last. Hydrochloric acid is always fixed. We dilute the sodium thiosulfate. Understand? It's called dilutes hydrochloric acid. You're not diluting the hydrochloric acid. Alright, so what you do is, for experiment 2, you have 20 centimeter cube of sodium thiosulfate and 30 centimeter cube of water. Is the total 50 or not? The total is still 50. So this is a constant. I'm changing the concentration only. Can I understand? Okay. So who do I add first? I can add this one number 1 and then this one number 2, but hydrochloric acid must be last. Or I can do this one number 2, this one number 1, but hydrochloric acid is last. Okay? So my solution of this sodium thiosulfate and water is in my conical flask. Last only I add the hydrochloric acid, then only I swirl to see the reaction. Okay? Can you all understand? Yes, okay. Now, look at this question B. In experiment 3, the student wanted the concentration of sodium thiosulfate to be the double the concentration of experiment 2. Okay, think a bit, please. Okay, do you understand? Now, how can I make experiment 3? How can I make experiment 3 double the concentration in experiment 2? What do I use? What sodium thiosulfate concentration do I use? 40. And this one, the water, I use how much? 10. And this one, the hydrochloric acid, I must use 10. Hydrochloric acid cannot change, right? Does everybody understand why I use 40 and 10 here? You must understand this one. 40 and 10 together, how much? 50. Okay, 40 and 10 total must be 50. Because the question says I want it to be double. 3 must be double of 2. The rate must be double of 2. The concentration must be double. There, it's written here. They want the concentration to be double of the concentration used in experiment 2. Get it? Okay. All right. Ready? Ready, okay. Use the collision theory. What is this collision theory? Oh, and the expected time, sorry. Expected time should be half lah. Because the more concentrated is the half, so here is 14. Do you understand? When it's more concentrated, you understand or not? Why is it 14? Yeah, because if it's double, then this one is half the time lah. Okay. Use collision theory. What is collision theory? Collision theory is all this. this whole thing that we learn here, the factors and everything, this whole thing is called collision theory. Okay? This is called collision theory. Alright, so why the particles colliding more often, everything. So the question says, use collision theory to explain why increasing the concentration of sodium thiosulfate would change the rate of reaction. Okay, so higher concentration, more particles per unit volume. More successful collisions. You can say more collisions, more successful collisions, both will give you 1 mark. It's 2 marks, okay? The student repeated experiment 1 using a higher temperature. Okay, so higher temperature. Using collision theory, explain why the rate of reaction will increase. So the same thing, okay? So remember just now I told you the 2 factors. So particles have more kinetic energy, more particles achieve activation energy, so more successful collisions. Or you can say more collisions occur, more successful collisions, anything also can. You will get 3 marks. Okay? Can you guys understand? Can you guys understand this experiment? Can I? Okay, can I stop share for a while? Okay. Okay, question 2 is exactly what we just learned about the hydrogen peroxide decomposing. Is the same as what we did. Now the difference is they don't ask you to draw a graph. This is a theory question. They don't ask you to draw a graph. They give you the graph and ask you to interpret it. Okay, so this was in the question that I gave you just now. Okay, so all right. So what happens is, the first question is, what is a catalyst? Okay, this one I will tell you the answer because this one the answer is very specific. Okay, what is a catalyst? Okay, so a substance that increases the rate of reaction by lowering the activation energy. Okay, a substance that increases the rate of reaction by lowering the activation energy. Okay, Ken? All right. Okay, so can you guys do the rest of the question? Okay, you do it now instead of homework, because I think homework you all have no time to do. So you all do it now and then you send it to me within 15 minutes, then we can discuss, okay? Can I please get a response? Ihua, what's your progress? Gahe? Not done yet. Ziyu? Ziyu and Matthew, are you guys done? Okay, we'll discuss in a few more minutes, okay? Okay, guys, let's discuss. Okay, because we don't have much time. Okay, can I discuss? All right. A student studies the rate of decomposition of hydrogen peroxide. Okay. Using the apparatus shown, the student uses 20 centimeter cube of hydrogen peroxide and 1 gram of manganese peroxide. Okay, this information is very important. Okay, the student measures the volume of oxygen given off at regular intervals until the rate of reaction stops. The graph is shown. So this is the volume of oxygen produced. Okay, so this is the graph. All graphs have this. When is the rate of reaction the highest? The rate is always the highest at the start. So you can always say at the start, or you can say when t equals to 0 seconds. Okay? At the start of the experiment, the reaction is always the highest because the concentration is always the highest at the start. Suggest one method of increasing the rate of reaction using the same amount of hydrogen peroxide and manganese peroxide. Okay, so you cannot talk about catalysts because they already mentioned the catalyst. So one method of increasing the rate. So you use higher temperature. Okay, use highest temperature. All right, did you guys get that correct? Yes? Okay. Can I? All right, next question. Calculate the number of moles in hydrogen peroxide used. Okay, so they already give you here 20, 0.1. So you use MV over 1000. Okay, don't forget the old stuff after you learn the new stuff. Okay, so you get 0.002 mole. Okay, 0.002 mole. All right, so use your answer in C1 and the equation to calculate the number of moles of oxygen. So if this one is 0.002, let's look at the ratio is 2 to 1. Remember we learned this before. The ratio is 2 to 1. So if this one is 0.002, this one is 0.001. Okay? Do you all remember why? Do you all remember why? Because the ratio is 2 to 1. Okay. Now, next question. Calculate the volume and RTP. Okay, so volume is the amount of moles times molar volume. Amount of moles is what you just calculated, and molar volume is 24. Okay. So you get 0.024. Okay. What will be the effect of the volume of oxygen produced if the mass of catalyst increase? Okay, what do you think about this? What happens to the volume of oxygen if the mass of the catalyst was increased? What's your answer? Ihua, what do you think will happen? If you increase the mass of the catalyst, will the amount of hydrogen peroxide change? No change. So the oxygen will also be the same. Okay, so no effect because you still have the same amount of moles. Okay, deduce the volume of oxygen that we produce if 20 centimeter cube, 0.2 mole. Okay, so no need to count all over again. If this is 20, if this is 20 at 0.1, and now they're asking you 20 at 0.2, you just double it lah, 0.24, 0.048. No need to count all over again, it's only 1 mark. Okay? Alright, the student carried out a second experiment to investigate. Okay, this is actually a 4-mark question. I didn't have place to put the marks. The student carried out a second experiment to investigate whether another substance, copper 2 oxide, is a better catalyst. Okay, is a better catalyst. Describe how the second experiment is carried out. You should state clearly how you will make sure the catalyst is the only variable. So what you need to do is you need to make sure you have the same amount of hydrogen peroxide. You have to have the same amount of hydrogen peroxide and the mass is also 1.0 gram. Okay, so you need to state clearly that you have to have 20 centimeter cube of hydrogen peroxide and it's also 0.1 mole per decimeter cube. Mole per decimeter cube. Okay, you have to state clearly. And then the mass is 0.1 grams of copper 2 oxide. Okay, why must it be 0.1 gram? That already gives you 2 marks. Why? Because it's what's given in the question. You can only change the catalyst. Over here, over here they already put here 20, 0.1 and 1.0, sorry, 1.0, not 0.1, 1.0 gram of copper oxide. Okay, so the catalyst is the only variable. Okay, then what you must talk about is everything else must be the same. Okay, so a student measures the volume of oxygen given off at regular time intervals. Okay, okay, so how do I know copper oxide is a better catalyst or not? What do? I plot a graph on the same axis as the experiment using manganese 4 oxide. Okay, so the reaction with a steeper graph or a faster rate is a better catalyst. Now, why must you mention the volume and of hydrogen peroxide, the concentration and the mass? Because everything must be the same. Everything must be exactly the same. Okay? Alright, do you all understand? Yes, okay. Alright, so that's all for today. Please, I will send you all the video later.